Okay. Next up, we have team 2511 of SCRAPS from Thessaloniki, Greece. They're a distinguished robotics team, currently competing 7 years in the first LEGO League Challenge. They're a collection of talented individuals with exceptional skills in robotics, mathematics, chemistry, and physics, united by their passion for exploration, research, and a spirit of great professionalism. They operate through a sophisticated five-department structure that maximizes their potential: programming, CAD, social media outreach, fundraising, and robot R&D. Please welcome SCRAPS. Are you all able to share the screen?
So do we share our presentation with you?
Can you please repeat that, please?
Should we share our presentation now?
Yes.
Okay. We are ready if you are too.
Yep, it's good. We can see it.
You all can start.
Wait, yeah, whenever you guys are ready.
Yes, thank you.
Hello, as I said before, we're Team Scraps from Thessaloniki, and this is our 7th year in the FLL competition. Being part of FLL has shaped us not only as engineers, but also as a team that shares values, creativity, and passion for problem solving. Today, we would like to take you through our journey this season. We will show you how our robot was designed, how our attachments evolved, how we programmed for precision, and finally, the strategies that helped us reach high scores in competition. Should we move to the next slide? Our journey has been full of challenges and milestones. One unforgettable moment was in 2022 when we became Greek national championships. That year, we even completed the robot game blindfolded to prove how reliable and accurate our engineering had become. In 2024 in Houston, we won the Engineering Excellence Award among 160 teams worldwide, something that made us realize how far determination and teamwork can take us. And in these seasons, in 2025, we placed in the second overall in Greece, in the first place in the robot game, the first place in the Knockout Awards, and in the second place in the Innovation Project Award at the championship. Our philosophy is simple: compact, balanced, and stable. We kept our dimensions small so the robot could maneuver easily but carefully distributed to the weight to keep the center of mass low and stable. Before building, we used CAD design and the virtual simulation, which allowed us to test and refine ideas digitally, saving time and avoiding mistakes. Then we followed an iterative approach: prototype, test, improve, and repeat. This philosophy gave us a robot that wasn't just powerful, but also predictable and reliable under pressure. In our 7 years, we have seen our robots evolve. We started with V3, which was powerful but less flexible. Now, with Spike Prime, we can program in Python, we can integrate modern sensors, and we can achieve much higher precision. This season, our robot was only about 15, 14, and 9 centimeters compact, but very stable. We optimized the drivetrain to reduce friction, we balanced power to weight ratio, and we used modern sensors for control. All these choices gave us smoother movement, consistent turns, and more reliable mission runs.
So, in our robot, we used two medium uh, two medium motors for our movement and two large motors for our attachments. We also use the touch sensor so that we can reduce our robot game time and not search every program in every run. And we thought of using a light sensor, but we didn't have a port in our brain, so we just keep that. Here you can see the center of mass of our robot for stability and accuracy in turning. And also to show our robot connectivity and stability, we used Studio 2.0. Here you can see our attachments. We used also a passive active mechanism and using the whilst showing the well done of both. So you can see and here is both active and passive mechanisms. Active mechanisms that work with the help of a motor, and passive mechanisms that need only the movement of our robot and not any other motors. Here you can see an attachment for the coral tree mission. Here. This is the attachment. One example is the coral tree mission. Here. The first prototype was unstable and had limited reach. Through interactions and we improved stability until we designed a balanced multiple purpose tool. It combined lifting and flipping in one mechanism, using gears and pivots to maximize control. This allowed us to complete multiple coral-related tasks efficiently in one run.
I think our presentation is stuck. You haven't passed to the next slides.
I think it's paused. Sorry. So this was the attachment that I was talking about. This platform, there was a motor in the middle that spins an gear, and this worm gear lifts this platform. Also, this orange part here rotates, in fact, and the cart in behind drops and solves another mission.
A strong robot is important, but strategy is equally critical. Our target was maximum efficient, more points in less time. We scored 620 points in 2 minutes and 30 seconds, which means about 4 points per second. To achieve this, we divided the field into color-coded zones, grouped similar missions together, and minimized attachment changes. The strategic approach reduced risk, saved time, and made our runs faster and more reliable under competition pressure.
So, innovation and challenge. Our unique challenge we set for ourselves was to use only parts from the previous season's models. This focused us to be creative and sustainable. So, our attachments, we used only the pieces from the last year's mission models, and we were so confident that were our first choice in our robot games.
Our program was built in Python and organized into modular functions. Each mission has its own code, but everything followed a standardized structure: initialization, movement sequence, conditional checks, and feedback loops. We use PID control to keep our robot straight and stable, even on long runs, and the gyro sensors for precise turns. The combination gave us movement accuracy within 2 millimeters, a big advantage when missions depend on exact positioning. By combining timers and counters and feedback, our robot became consistent and repeatable, which is exactly what you need in this competition. What made our process effective was the integration of mechanisms and software. We didn't build first and code later. Instead, both evolved together. Every time we made a change in hardware, we adapted the code. Every time we changed the code, we rechecked the hardware. The continuous feedback loop allowed us to constantly refine stability, precision, and performance. It was a cycle of design, build, test, improve over and over again until everything worked as one system.
So as we mentioned before, it's our first 7th year in the competition. We had much fun in this season too. We are very proud of our achievements and we are happy to get any questions for you or comment, get in touch with us. So we have here on socials any questions we are happy to answer.
Do we have any questions? Up there?
How do you adapt the report cards to each year's game?
So the first question was. We're good? Okay. The question was, how do you all adapt, the recycled parts from last year's to this year's theme?
So we broke down the mission models from last year and used the pieces that we got from there and created our attachments for submerged season.
What else from online? Online, they're asking, what is the CAD tool you used for simulation? And do you recommend CAD programming books for coaching and learning?
Can you repeat the question because I didn't hear you?
What is the CAD and simulation tools you guys use?
In the CAD, our attachments, we make them. Sarah, do you want to answer?
Yes. So in the simulation, we took our robot model and put it in simulation to see our stress parts and how every piece was connected with each other, and if it was any flaw in the building of the robot.
Got it. Thank you, guys. And unfortunately, that's all the time we have right now for questions, so we're gonna move on. People in the chat, I think there's another question that, Scraps, you guys might be able to answer in the chat. Thank you.
Yes, of course. You can take our socials anytime. You can send us a message, and we will be happy to answer.